Okay, thanks everyone for coming. The reason I'm doing this is we have a reputation at RMA that we know how to design an expensive clay soils, and I think what I want to do today is explain how clay absorbs water and how we design for it, and just a few things not to do. So it is a bit interactive. You can interrupt me and I may talk to you, I may not. So basically that's my engineering 101. The ground holds everything up and the ground can move. Now clays, if we, oh, I go return to it.
If you click on it, it should just go.
Yeah, it should do. I don't know what's going on here. Okay. So basically, there's a couple of clay types. So each individual clay layer is basically structured around aluminium and silicon atoms. You get a silicon layer, which is a silicon oxide tetrahedral sheet, which is, oh, you can't see my arrow, but that's the guy on the top right, silicon atom in the middle, 4 oxygen atoms around it. That forms a lattice, and that's called a tetrahedral sheet. And then you get an aluminium layer, which is aluminium hydroxide octahedra, which is the bottom guy. Now, so clay minerals are just made up of repeating layers of either silicon or hydrated alumina sheets. And there's 2 main types. So you get a
blank page.
You either get a 1-1 type clay, which is the guy A on the right, which has just got alumina and silica sheets, and in between the silica and alumina sheets there's a very strong hydrogen bond, and basically water will not get in between those sheets and force them apart. And your 2-1 type clays are silicon, alumina, silica, and depending on the bond type, they're the bad guys that water will not only, I'll get it on the swell mechanism in a minute, but water can get in between those sheets and physically force them apart, which is the basic thing for expanding clays. Did I hit page down there, do I? Or return?
Page down.
Now with clays, there's 2 mechanisms of swelling. The first one is, like, clay particles exhibit a net negative charge, and water is attracted to the clay's negative charge. So the top one is a 1-1 type clay, and it starts just absorbing water around the clay particles, and that will swell a little bit. So 1-1 type clays, that's basically they're done. And the next one is the 2-1 type clays. As more water becomes available, it starts to get absorbed in between the sheets and can force them apart. Does this make sense? So depending on the type of clay, it will depend on which sort of bond you've got between those alumina sheets. Like with a kaolinite, it's just got a very strong hydrogen bond, and it doesn't expand very much, and it can absorb about 70% water by weight. Illite, which is the guy in the middle, which has got a strong potassium bond. It does the macro expansion, then micro, and it can absorb up to 200% of water by weight. And then you get the bad guys, the montmorillites and smechites, which have got a weak oxygen bond, and they can absorb, in extreme cases, up to 700% of their weight, macro then micro. So they're the bad guys that we have to deal with. Now, when we talk about, you'll see a lot of soil reports and they predict YS, which is surface movement. And the big thing you've got to understand with the YS value that the soil guys report, or you see in a soil report, is it basically, it just assumes normal moisture changes due to normal climatic conditions. Like, the location is important. If you've got the same clay on the coast where it rains every second day, it might have a YS of 70. Same clay out of Dalby, 130, 140. So it's also the depth of the clay layers. So if you've got a shallow bit of clay over rock, it won't swell as much as if you've got deep-seated clay. because that depends on, so typically in Toowoomba, our range of moisture content, what is it these days, 1.8 still, Dean? 1.82 metres, and the further west you go, it can be up to 4 metres deep when you get out in the bad drought areas. So then you get a site classification, which is, I don't know if you're all familiar with that, that's just a table out of AS 2870, the residential footing code. And a lot of soil reports you get for commercial stuff won't reference that, but it is a good guide. So basically, A down to H1, nothing much to see here. It's a piece of piss design against them. It's the H2 and E footings are the ones we're focusing on today. So the H2 and E, it kicks in about 90 mil surface movement. So when you get a geotech report, I don't know if any of you are aware that there's the Unified Soil Classification System, which all good labs should describe their soils by. I don't know if you can read that very well there, but you've got gravel, sands, silts and clays, and silts and clays in the second order. So it's really when you get, if you go down that list and you get into the clays, all the MLs, CLs, CL clays are sort of your M's, H1 type clays. They're those like kaolinites, those sort of clays that don't have that much of that secondary moisture absorption, and the ones down the bottom are the CH clays. So it's basically anything with a liquid limit over about 50, but some of the liquid limits can go, what's your record, Dan? Over 100? 120, yeah. So they can get very, very bad. So basically I just treat all clays with a YS over 90 the same. You just treat them like they're going to kill your building, and you design accordingly for that. So it's interesting that, like, basically from a mechanical perspective and for designing footings, that classification goes from very bad footings, very good footings up the top to very bad. And if you're a farmer growing crops, it's the other way around, because the clays, their ability to absorb and store moisture is what dry crop farmers want, which is why people are living out on the downs growing wheat and stuff like that. So I've done a lot of work over the years, and I'm basically going to list you some footing schemes in order of effectiveness and how you can deal with building on these highly expansive clays. So all these systems rely on great drainage and other practices. Basically, the only reason these clays expand is if they're exposed to moisture. So if you picture them like a hibernating grizzly bear, it's sitting there and it won't harm you unless you put water on it, and then it will try and eat your face. So the first option is to get the whole thing so it doesn't touch the ground, so it's fully elevated off the ground, either timber or bondeck. So we've used that quite a bit for residential and commercial, like McLean's grading floor is all fully suspended off the ground. It's also handy, we use it in Dalby, you can let flood water pass under the building as well. And I'll show you, I'll go to the next page first. It's a bit small scale, but typically this is a residential job we've done. And you can see the pier up the top there. Basically what we're trying to do is not have any of the structure touching the top 1.5 metres of the clay. So we put an overbore, a former tube liner and a gravel backfill around the clay, so the clay can't grab the pier and pull it out. Because if you just do like a 5 metre deep pier and you don't do that, the clay will just grab the pier and snap it. So it's very important that you do that. So if you're doing an elevated building and it's got flooding, you do it on all of them, but generally I just do that overbore on the wetted perimeter, because the internal should just dry out. I'll just go, where's page up?
Above, page down.
Oh, thank you. So the advantages are, it's the best option because you get, everything's out of the ground. The clay, where it's expanding and contracting, All your surfaces are fully suspended in the air, and you've just got one dropper into the ground, so you avoid breakages and that sort of thing. So the disadvantages, especially in the commercial world, is it's above the ground, and you've got to have ramps up to it and deal with those sort of things. Here's an example of one that's, Craig will recognise that, that's McLean Farms grading floor. That's the former tube liner. We just come out of the ground, and that forms our column to get it out of the ground. But below that, there would be an overbore and backfill with gravel. So that one's a Bondex slab, obviously. Now the next one is fully suspended on void former. This is basically looks like a slab on ground, and basically we use void former, which is just collapsible cardboard, to form the void underneath. So it's still a fully suspended system, but the main disadvantage is if you've got a lot of drainage under your slab, I prefer to have the drainage fully encased in the structural slab, otherwise you can just cause you grief. So it's difficult to do that. So we just spent a lot of time trying to convince the architect in Melbourne that the CSIRO job we're doing should be done like that. And I think we're over the line on that, but it's taken a bit of time. For the guys in the built environment team, you'll realise we've got some standard designs that you can just sort of, instead of doing a full analysis on these, we just basically do a 3 to 3.5 metre grid of piers and just read off the standard tables. Now typically when I'm doing designing piers in black soil, I just ignore the end bearing, because it's you can't reliably check that they've cleaned the holes out. If you ever look down a 5 metre hole in black soil, there's not much to see. So typically you get about 100 kilonewtons working load out of a 300 pier and 200 out of a 450 pier. And you might use 200 kPa end bearing, which technically you could probably push that up to 600, but use about a third off what you're allowed, and that'll get you a safe design. Here's again the grading floor. This is fully suspended on Bondeck. That one used timber piles, which I like as well, because they're a small diameter and they're quite smooth and don't give the clay much of a purchase to pull itself out of the ground. That, if you're not sure what void former is, that's that pile of cardboard over on the side there. So basically just burying it under the ground, it stays. We wrap it in plastic, so for the first week or so it's at least strong enough so that it'll support the wet concrete, but then it just rots out and forms a void, hence it's called void former. Now the other one that I think I started using this 25 years ago, when you do a lot of sheds and commercial buildings and black soil, and it gets really expensive if you want to suspend the whole building. You're talking an extra over a 150 slab on ground to a 170 suspended on piers, probably $180 to $200 a square metre. And if they've got big sheds, people balk at that. So what we do is suspend the perimeter, the theory being that if you go around the 2.5 metres around the outside, by the time you get in that 2.5 metres, the effects of climatic change, the soil moisture content should be very stable inside the building. So advantage is it's cost effective for large sheds, but you just got to be a bit careful. If they want to put petitions and offices inside, you'll still get some movement in the centre section. So you just got to find out what the client wants and what they're going to use the shed for. So here's one I've prepared earlier. This is WeWar. It's a big shed. It's 60 metres by 180 metres, and to fully suspended on black soil is just ridiculous. So we've done around the perimeter, and that bit jutting out the top is offices, and because it's got petitions and stuff that's sensitive to movement, we suspended that as well. Here's a typical section. Now if you look up in the top left, that's the typical perimeter detail. That one there had some specific thumb. We normally wouldn't suspend the slab edge over the thing, but there was a specific detail the architect wanted there. So that is what it looks like when it's getting prepped. That's you can see the void former poking out there, and that's what it looks like when it's finished. So they get a join there, and it looks quite neat. So all that stuff from that 2.5 metres in, the soil's shrinking and swelling on the outside, and your system is basically fully suspended. It's really good when there's no plumbing or other trenches and everything that can lead watering.
Did all the Dunnings get that done that way too, Lee?
What's that, sorry?
All the Dunnings, did it get done the same way?
Yeah, exactly the same way. We did some tricky things on that. We used the tilt panels as edge beams and did some tricky shit, but basically the same thing. The other one is people just want to, you can build a fill platform and reduce the YS, the surface movement. So a typical black soil has a shrink swell index, which is ISS, if you see that in soil reports, of about 6. So in Dalby, with that climatic condition, that equates to about 130 mil YS. So there's two options there in green and yellow for the colourblind. One is, you know, the typical Dalby, what they call their Dandine gravel. If you put that to 1 metre deep, it'll reduce the YS to about 87, but if you go 1.5 metres deep, it gets it down to 55, which gets it into areas where you can do just normal high-level strip footings and, you know, nothing, you know, very spectacular. So that works quite well if you have to build a site up to get it out of the flood levels, so you can do that. So, and they're the sort of design options you get. So, but it really is, rule of thumb, you need at least 1.5 metres to make a difference. 1 metre's still not quite enough for me to be comfortable. So typically that wee wall one where that shed was had about 1 metre fill, so we still suspended it. But on the other end of the site we had the admin and lab buildings were on about 2.5 metres of fill, so we put a stiff raft on them. So it's just a matter of looking at how much fill you got and which options you need. What up next? Things to avoid with option 4. You may or may not be aware, I added some standard notes about down the bottom there in imported fill parameters. So the worst case would be if you just put straight sand in there, and if you just picture that, the water would just go straight through and it just would pond even worse on top of the black clay and cause YS movements even worse than you're trying to avoid. So I've come up with there, so it's quite a generous thing. It's got a linear shrinkage between 8 and 15. It's basically, you don't want really good fill, you just want just nice fill, Goldilocks fill. So you want it to shed water and be that sort of M's type soil, not S type bony soil. So yeah, so basically what you're trying to do, but also when you do that, you've got to make sure before you place any fill, your natural soil should be shaped and free draining before you place it, because I've seen houses in Gundawindi where people, you know, sloping site towards the river, they build up a big fill platform, the water just ponds up against the fill. It's like a time bomb, it just takes 5 or 10 years to eventually seek under the house, and they wonder why it's popped up. So it's important to get that, and we spent a lot of time, we actually did cross sections of the natural material and told them they had to get that signed off before they place the fill. Service trenches. Now, raft slabs and void former suspended slabs, service trenches are basically, you're trying to do all this thing to stop moisture getting up, and then you're building service trenches, placing crusher dust fill against all your pipes, which basically, that has got a permeability many times greater than the clay. So any surface water going through will just get in that trench and just go each way all along the trench and end up underneath your building. So a couple of examples again at Weewar. This is what Marline sent to us, and you can see at the top they just wanted to run the water main straight under the building. I told them no, it's got to go around. And then they've got a forest of stuff at the bottom here, so we had to specifically say what the hell's going on there and make sure they're far enough away from our building. And also with the plumbing, they came out of the building on the right, then they wanted to shortcut and go underneath it again. And again, that's just asking for trouble. You've got a service trench heading towards your building and under it. Bearing in mind this is a raft slab. So we told them to go around, and we also tell them to put clay bridges across the bedding layers where those magenta sections are. So you can do that with, you can buy bentonite clay in 25 kg bags from rural stall shops. They feed it to cattle. They'll mix it up with cattle feed. So you can put it in, you just get rid of the sand or crusher dust for half a metre, pour your bentonite in or your natural clay, and basically you try and stop it about every 10 metres just so water doesn't track back in. And particularly electricians are the worst at this because they will just dig trenches straight towards the building, generally downhill. They won't backfill them properly, and it's just, they just don't care. and water will just track in, and as soon as it starts tracking in, those clays just love to absorb water, and those YS values are for normal climatic conditions, and as soon as you start to put ponding water over a long period of time, you can easily double that. So even the best designed footing can fail. Here's a couple of examples of, I've seen a lot of stuff over the year that makes an appearance. Waffle pods get a surge every now and then. We only use them for M sites, the main reason being the whole system is flawed. It's all above the ground on a crusher dust bed, and if you don't get the drainage 100% right, you're just inviting water to go straight underneath the perimeter of the slab, and it just ends in tears. So, and there's a new system out called couple X slabs. Again, just the answer is no. I've been saying no for 20 years, and I'll still say no. One, I'll just put this second one is, I haven't seen it come back because it must have failed so badly, but if you ever see it surface, there's this guy that had this system that he used to scarify up like he was planting a crop, saturate it for a week, and the theory being, oh, it's heaved as much as it's ever going to heave. So then he's got his screw piles in, then he put a suspended slab on it. There's a house out near the Toowoomba Showgrounds that's never been lived in because it stuffed up before they got the roof on. And the other one, sometimes there was a theory that you use a big edge beam, like 1500 deep, as a moisture barrier. It's flawed as well because in the areas we're talking about, the soil moisture content changes over a 3 metre depth, and also the soil can bind on the edge of it and drag it up as well. So then you've got to run services through the edge beam, and don't do it. Short answer. Well, I think that's it. It's just as I say, it's an introduction. I'll probably get into some detailed areas about site classification and other things, but any questions?
What if your YS is 89? Do you just...
Then it's 89.
No,
It's always one, it's always you.
No, anyone who's
so
reads
close to 90.
no anyone who reads soil tests that closely does not understand soil. If I see black in the soil test, like I haven't got a soil test in Dalwood for 20 years. I know what it is. It's only occasionally when you get an architect from Sydney who insists on one.
Just so you can prove your point.
Like we got one down at CSI Row, mainly because I got a 13k job for the soil boys, but otherwise I wouldn't.
We kind of knew what was there.
Otherwise I wouldn't have bothered. So that's it. It's really just understanding the nature of how it absorbs moisture and its ridiculous amount that it can absorb, and like even things like, I know I don't like cut-off drains and ag pipes around things to protect pavements because it can introduce water. So it's really just understanding how it works and just being a bit wary of it. But there are certainly ways to deal with it. The best way being go nowhere near it and have everything up out of the ground.
What about trees around footings?
Trees just suck moisture content out, and they're more a problem in M-type soils where the failure mechanism is generally due to dry conditions, but with blacks and expansive soils, it's dry, wet and everything in between. I've even seen a job, we did the community hall out at Yarra Junction. They drilled the piers, I inspected them in the morning. We got about 20 mil of rain and it physically closed the top metre of the piers up and they had to re-drill them.
Mm-hmm.
So when you see that sort of stuff and you just understand what you're dealing with and how to avoid it. That's it. How'd I go for time? 4 minutes early.